Hello, Algebra 2 students. If you're looking at Fry's, Leininger, substitute, whoever is going to be there, direct variation worksheet, I have some help for you on the odd problems. Go ahead and do the even problems on your own and go ahead and make mistakes. We learn that way. Try them out. At least get these odd ones done. The question is, or the directions for these first problems are, is each equation a direct variation? If it is, find the constant of direct variation. If not, explain why. And there's a lot of help right here in the directions. Remember that direct variations have no constants. Those are those numbers after the x, like added or subtracted, the y-intercept, in other words, they have none. Because if you were to graph it, it would be going directly through. It's a linear equation going directly through the origin. That's going to be a direct variation. And are in the form of y equals kx. This k, just, think of constant spelled with a k. This is the constant of direct variation, different than the other constant, where k is the constant of variation, or the slope. So you're going to have a slope, you're just not going to have a y-intercept. Solve for y and see what you get. So when you go ahead and solve for, you could tell already this has a plus -1 out here, so that's going to be, it ends up being minus 1/2. So there is this constant out here and the constant of direct variation, but because it has this constant here, no, it is not, because it doesn't look like that. Y equals kx, where there's just a constant of variation or just a slope. This has a y-intercept. The y-intercept is going to be at -1/2, so it's not going to go through the origin. If we were to graph this, it's not going to go through the origin or the center. This one, -1/2, is going to go through like down here, -1/2. It's not going to go right through the 0, 0. All right, so let's take a look at number 3. Here we have an example of one that is a direct variation, because you just end up with, when you're solving for y, I end up dividing by 6. I ended up moving the y over here and the x over here just so it looks more like this, so it's a little less confusing, instead of the y. The y could be on the right and the kx could be on the left. That's fine. It's still the same thing, but I want it to look like the directions if you're just getting into this. So y equals -2x, it ends up being, because -12 divided by 6 is -2, and there is no y-intercept, so that means it's going through the origin, and it's just has the slope of -2, so it's going down 2 over 1 out of the origin. So yes, it has direct variation. This one also. I subtracted 5x from both sides. I then divided by -6. I end up with 5 over 6x. Y equals 5 over 6s. It looks like that y equals kx. My k, or my constant of variation, the slope is, it goes up 5 over 6, right out of the origin, because there is no y-intercept there. That means it's going to go through 0, 0. So yes. Go ahead and try 2, 4, and 6. Number 7. And you could pause this video as needed. I'm going to just rip through it. Point A is an element of a direct variation. Identify 4 points other than A that are also an element of direct variation. So that means, what they meant to say is other points on the line, if that is one of the points on the line for direct variation. So if this was if this is a point on a line for direct variation, remember it has to go through the origin to be a direct variation. So I would go down 1 over 3, and I'm going to keep doing that backwards, down 1 over 3, down 1 over 3. It's actually an up 1 over 3, because you read it left to right, but in order to figure out where I needed to put these other points, I went backwards. So this is it's actually a positive 1/3 slope here, my constant of variation. So, up 1 over 3. So this formed a straight line through the origin. So these are the other points, and I named them here. -6, -2, -3, -1, and you can see the rest. Obviously, 0, 0 needs to be there. That's why it is a direct variation. Okay, for these, are the following tables examples of direct variation? If so, state the constant variation. And this hint is a big clue as how to do it. Hint, make sure that the y divided by x, that ratio, y to x, is the same for all points. That's how you know it's a direct variation, and there's a constant. The constant variation is that y divided by x. So this one's yes, because every time I took, -2 divided by -3, I got 0.66. 2 divided by 3, 0.66 forever. And 6 divided by 9, 0.66 forever. That 0.66 is 2/3. And so it's, the slope of this is going to be, it would be y equals 2/3 x, or up 2 over 3. All right, try 10, 8. It looks like 1, that should be a yes, and 10, I tried, it should be a no, and you could figure out why. Number 11, this is a yes too, because every time I took y and divided it by x, I got 1.4, so it would be the same. So, my equation would be y equals 1.4x. They're not asking for equations here, they're just asking for the constant of variation. The constant variation here is 1.4. Okay, are the following graphs examples of direct variation? If yes, find the equation. If not, explain. So this was 13 is a yes, and here is my equation, because I just go back and get a couple dots here, and I can figure out the slope. It goes up 1 over 2, so it's 1 over 2, a positive 1 over 2x. Positive because it's going up. You always read it from left to right. It's going up, so it's positive. I went ahead and because I was interested in these, so you could take a look at these, and 12 you should have no, because it doesn't go through the origin, and 14 no, it's not linear. It has to be a linear equation. Even though it goes through the origin, it does touch the origin, it's not linear. 15 says write an equation of a direct variation that includes the given point. And the given point here is -8, 10. So this tells you exactly what to do here. Find k, and k equals y divided by x. So just take your y divided by x, so 10 divided by -8. I end up getting -1.25, or that is -1 1/4, or you could call it -5 over 4. I like leaving it as a improper fraction, because that tells me my slope. I'm going down 5 over 4 if I were to graph it. Even though I'm not graphing it, I just like it like that. So that's my new equation. I just plugged that k value that I solved for back into the equation. How did I get that k value? From what they told me to do up here. I took the y divided by x. Y divided by x gave me my k, that constant variation. Try 16 on your own. 17, once again, to find k, you take the y value and divide it by the x value. So it's -10 divided by 5. -10 divided by -5 is 2. So that's my k value. So I just plug it back into the equation. Y equals kx. My k is 2. So for any x value or y value I get in here, I'm going to multiply the x value by 2 to get my y. So the slope is 2. It goes up 2 over 1. And the last one, try 18 and 20 on your own. 19, the weight of an object exerts on a scale varies directly with the mass of an object. If a bowling ball has a mass of 6 kilograms, the scale reads 54. So here I just pointed out a few things. The input, or the independent variable, the x, is the 6 kilograms. The output, or the dependent variable, is 54. That's your y, okay? So write an equation. So remember, in order to get that from back up here, to get that constant, I'm going to take that y divided by x. So 54 divided by 6 gives me 9. That's my k value. So my equation for the relationship between weight and mass is y equals 9x. So I go ahead and plug in this problem, ask if another object has a mass of 8 kilograms. What would the scale read? So you just plug in 8 for x, because that's the input, and you multiply it by that that constant, that variable, the direct variation constant there, your k, and I have y equals 72. So hopefully this helps, and try the others on your own, and good luck.